Hi, today we are going to discuss the variable frequency drive. What is a variable frequency drive? So I'm giving you basic introduction that variable frequency drive is a type of adjustable speed drive where actually you can control the speed of the motor, and it's a electromechanical drive system to control the AC motor speed and torque by varying motor input frequency and voltage. As the name suggests, it is going to change the frequency of the complete power which is being given to your AC motor, and that way it is going to control the speed. So variable frequency drive, as the name suggests, is only going to change the frequency of the power. Based on that, the speed of the motor is being controlled. So that's the basics of the variable frequency drive. Now coming to kind of the drives that we have is basically electrical drives, where you actually change basically power from a basic power to a motorized power. Like you have got different types of systems where the mechanical energy is being created by using diesel, petrol engines and all those things. So electrical motor is also one of the component of that, where you actually are giving electrical power, and the electrical power is being converted into mechanical power in the form of rotation energy, and that is called the motor. So at the variable frequency drive, this is primarily focused on the conversion of that electrical energy of being given to that motor, and from that motor the mechanical energy, the control that we give, is called electrical drive. And the type of the drives that we have been using in the industry are DC drives and AC drives, because in the early part of the century of the start of electricity in the world, we were basically using the DC drives because the DC power was easily available, it was easy to be created. So most of the motors, most of the things which were created early in the start of the century were basically DC powered. So based on the DC power, the DC motors were developed because of the heavy torque and all those things. So the control of those DC was basically done by the DC drives. And as slowly the advent of the AC power came and the people started to use the AC systems, so the AC motors also developed. And based on the AC motors, the drive systems for the AC drives were also developed. So it's pretty simple. AC motor uses AC drive and a DC motor uses a DC drive. Now, what is a VFD? If you know, as I have already explained, a motor is basically providing a rotational energy. So it is actually rotating based on the power given to it. And VFD does the control of the frequency of the complete power which has been given. Our normal in India, the power frequency is at 50 hertz. So that is the 50 hertz frequency and a voltage of say 400 volt. You will have a standard RPM of the motor like 1440 RPM motor is there. So it will be rotating at the same speed. Variable frequency drive actually controls that frequency. So it can increase or decrease the speed of the same motor by providing the change in the frequency. So that is called variable frequency drive. It may look like this. There are different models available in the market. Now, which are the, how you actually explain what kind of the drive is there? Like, so the main component of this system is basically, first is the AC motor. As you can see, the AC motor is actually going to provide the mechanical energy. Then we have got in the VFD, we have got the main controller assembly, which is actually doing the control of the power. So if you see on this right hand side, there is a complete architecture which has been made. So the power comes from the top, or you can say the incomer to the VFD, and then it is being controlled based on the need, and then it is being fed to the motor. And there is one operator interface. This operator interface job is basically to show you that what is the speed, what is the frequency, what is the power, what is the quality of power, and all those things, because you need that information directly in live. So the operator interface actually provides you that kind of information. Most of the time in the industry nowadays, we are using the three-phase power. So the motor, if you see, will be mostly three-phase. Although there are single-phase motors also being used. So there are different type of systems being used to control the speed of those single-phase motors. We will confine our discussions and presentation basically up to the three-phase induction motor only. So there are different starting methods. There are different controlling mechanism for the other type of motors also. We have currently focused only on three-phase induction motor. So as you know, the three-phase induction motor is basically providing a motion control, a rotational motion control, and the basically as soon as the power is fed to this, It's a standard Faraday law. So magnetic field is being created and the rotor starts moving. So it's a pretty simple mechanism. Everyone who is having a basic level of engineering understands that as soon as the power is given, the magnetic field is there, and the rotor starts moving in a particular direction to provide you rotational energy. Now, in the variable frequency drive, we have got three main components. First is the bridge rectifier, and second is the DC link, and the third is the inverter. So these are the three main components who actually help you to actually control the complete power system being fed to the motor. Now this is a basic architecture, or you can say a diagram of this. So what happens is, if you see, we have got a three-phase motor. So we have got a three-phase power coming up. So you have got RYB phase. So all the three phases which are actually giving some power, they are actually given, and they are actually with the bridge control rectifier. We are actually controlling the complete AC, and from the AC we actually convert it to DC. So AC is sinusoidal in nature, and DC is actually, the waveform is actually on the one side of the voltage. So it will be either positive or it will be negative. So if you see, it's a standard basic three-phase rectifier, and on the top of this right side is basically three phases are going. So all the three phases are in different colors, you can see. So as you can see, this the topmost right side is basically showing three types of the waves. So these are all, if you can see, are sinusoidal waves. So they actually move towards the both the axes. So sometimes it's positive, sometimes it's negative. As soon as the rectification happens over here, you see all the waveform is actually going towards one side only. So it's a DC waveform which is being created by the rectifier. The next step is the DC link. Basically the job of the DC link is basically to convert the complete sinusoidal wave into a quasi-sinusoidal. What it means is, basically there is a waveform which is basically, if you see in the last waveform, you see this is basically, the waveform is actually getting lot of sawtooth kind of output. Okay, so the job of the DC link is basically to make it quasi-sinusoidal. So the kind of the disturbance which is actually in the DC circuit is being reduced by the DC link. So DC link is basically measuring, and it is actually trying to smoothen the complete curve. So this is the job of the DC link, so that it can actually reduce the losses being created because of that curve. Then is the basic inverter. It's a standard inverter where the DC power which is being fed from the rectifier section is actually being converted to an AC. So it's a standard inverter which we are actually using in our homes also, and this is the same inverter, but it's a three-phase inverter now. What it does is gets a DC input, and based on the DC input, it is actually giving one AC output. So basically what we do is we actually control the output circuit of this, where the switching actually happens. So it is always on off kind of the switching happens, where you get a complete waveform in the similar fashion where you are actually getting the AC waveform. So in the beginning what we did was we converted the AC to DC, we smoothened the curve, and then again we have converted to AC. Now here we have a control of the switching, so here also we actually control the frequency. So based on that frequency, you are actually able to control the power. Now this slide is actually showing you the basic operator interface. This is a standard with most of the VFDs, where actually you are able to do programming of the VFDs. You want to do some kind of adjustment, you want to see some displays of the parameters, you want to do some kind of control on this. So the operator interface, as the name suggests, is basically being used to control the complete variable frequency drive. So the whole information, whole programming that needs to be done for the drive is done through the operator interface. It's one of the most important part of a VFD. Now, as I have already explained, this is a consolidated diagram of the complete VFD operation. In the beginning, on the left side, if you see, the three-phase power is coming. So the three-phase power is basically converted to a DC. So it's a bridge wave rectifier. It converts the complete power to DC. From the DC, then you have got a capacitor in between. The job of this is basically to smoothen the curve. So whatever the disturbance is there in the DC circuit, because of the AC input, automatically it gets smoothened, and the same DC is being fed to your inverter circuit. So if you see, we have got inverter circuit at the end. This inverter circuit is basically giving output, converting that DC power to actually an AC power, which is being fed directly to the motor. So if you see, this is the waveform characteristic. This is more explanatory to you how it is going to work and how the motor actually gets affected. So if you see on the drawing, there is a sine wave power. So you have got a basic power which is coming in the form of sine wave. So it's a sinusoidal wave. It's the perfect AC power which is you get in your through your power supply company. Variable frequency control changes this to DC first. From there, it actually again changing into AC. And if you see, there is this power waveform is something like this. This is not a pure sinusoidal. So it's more kind of a pulsed variable frequency power is coming. But it is okay with the motor to that, because based on the change in the flux, automatically the motor gets that magnetized and it starts working on this. So, and the effect of this sinusoidal wave and the not so perfect sinusoidal wave is not very high on the AC motors. So the behavior of the AC motors remains the same as per the requirement, but you also get an additional control on the frequency. So this is the way it is going to work. Now there are different methods where you can use the frequency control, but the most and the best method which is being used for the frequency is the pulse width modulation. So most of the electronics guys know it, but this is an electrical subject also, because you actually control the width of the pulse that is going out. So if you see the previous slide, so you can actually increase the frequency from here. So the width is basically being controlled. So whenever the width is being controlled of that pulse, automatically it controls the frequency. And it's a standard technology now is being used everywhere across the globe, and this is highly efficient and this is highly safe for the motors. So if you see the waveforms, in the waveform you will see the change of the voltage is coming up. So you will see in the width modulation, the voltage actually goes to one level, then again it stops, it again comes, it again stops, it again comes, and it comes down. This is basically the frequency which we are controlling from the switches, or you can say the inverter. And the current output based on this waveform is actually something similar which is shown in the sinusoidal wave format. So basically this is what is going to change or you can say control the motor. So what happens is the VFD, what it does is, it has got at the output, it has got basically IGBTs or thyristors or transistors. Basically these are the components of the VFDs which are actually converting your AC to DC and from the DC again to AC. So these are the devices which are basically switching devices. These are basically on and off devices. So you will get sometimes on power, sometimes off power, and based on that we are actually able to get a proper frequency. And now these actually are also being used to do two types of controls, like VFD can also control the output voltage, and VFD can also control the output current also. So these kind of the things that also you can do that. Now constant current and constant voltage drives, that what we have seen is basically most of the time if you see the VFD switching is basically controlled, and we already have one DC link in between for the smoothing of the curve. So what you can do is you can actually control the voltage, you can actually control the current also going out of that VFD. So that way you are actually able to control the amount of the power being fed to the motor. So that is the real control that you can get with the VFDs. Now these are the few of the effects you have to be taken in consideration of using a VFD. Because the VFD is basically one way controlling system, because it is going to give the power to that motor. But you must have seen mechanically what happens is in the motors, the motors also have their self-cooling mechanism. There is a small fan on the backside of the motor. Now that backside of the motor is something which is actually, that fan is actually cooling that motor, because motors also get heated up. So if you reduce the speed of that, the efficiency of that fan also goes down. So you have to be very careful that wherever you are going to use these VFDs, you should have a proper ventilation, or in case the VFD speeds are going very low, like they are going to say around 20% or 30% of their rated speeds, it's always better to provide an external cooling fan outside that motor so that the motor remains cool. So that is very important factor that you should be using whenever you are using VFD with a motor. Be sure that till how lower side you can get the RPM. So if your RPM is 20 to 30% of the actual rated speed, better to put in a extra fan for the cooling of that motor. Now, when the frequency reaches 0, motor is shut off. So this is very important because the frequency controller is giving you an output. Although you can lock in the frequency, like you can have a RPM of up to not lower than 30%. So below that, then the motor will keep on running. But there is a challenge. Sometimes you have got a safety application and the requirement of the control actually goes the frequency to 0. So there is a possibility of motor getting stalled. So motor getting shut off. So it's always recommended whenever you are putting some VFDs for a particular application where the safety is very important for the machinery, you should make sure that you lock the VFD for a minimum RPM. The RPM should not drop below that irrespective of any conditions. Otherwise, if the RPM goes below that particular condition, the motor will switch off. And the motor will switch off, your load will be off, and there could be causing some kind of a problem in the system. Then motor may also need load reactance and filters sometimes. This is basically the reason being is the VFD output. If you see, the VFD output is giving you a switching output. Now the switching output, if the distance is very less, is not going to make a difference on the motor. But if that switching output actually goes for a longer duration, so what happens is you actually get a backlash also. So once the backlash comes, you have a very big challenge with that. The backlash is actually affecting the drive circuit itself. It is not affecting the motor, but it is affecting the drive circuit also, because it's exactly the opposite which is being generated by the drive. So it's some kind of a short circuiting which happens, but normally it happens with a longer distance cable, like you have got a distance of cable is going say 500 meters, 600 meters from the VFD. So sometimes those kind of challenges come up. For that, you can actually put sinusoidal filters, you can put reactance, and all those things are also there available. We can provide you a study of the complete thing, how much longer cable can go with the standard VFD. And based on that, you can decide on putting a line filter in between or not. Now coming to how the energy saving is being achieved by using a VFD. Now you are aware that most of our loads in our plants are either pumping loads, or either they are compressor loads, or either they are the conveyor loads. So these are kind of the three loads that we have. Now all these three loads have got one thing in common. All these loads are actually using a motor. So all the motors who are actually controlling these kind of three loads, compressor loads, your conveyor loads, or pumping loads, they are all motors, and all these loads can be controlled very well by a VFD. Although the characteristics of controlling that load will be totally different, because the compressor has got a different behavior, pump has a different behavior, and conveyor has a different behavior. But still, normally whenever we are actually sizing a motor, the motor is sized almost 20 to 30% higher than the mechanical loads, just in case there are higher loads or there kind of a design problem. So your motors are already 20% higher than the actual load. So that is the basic design philosophy we actually follow across the globe. So whenever you have a pump, your pump is delivering some kind of a product to the plant, like whether it's giving some kind of a chemical or a water, cooling water is there. It is compressor is providing some kind of air over there. So all those things are happening. And if you see, most of the time what happens is these motors are running at a full speed. Full speed means they are actually giving you a complete process at a highest level, so that the last point of delivery has got that kind of required pressure. So that is the basic philosophy that we do. So suppose your last point of delivery in your plant needs a pressure of say 7 kgs. So at the delivery end at the pump end, pump delivery, you actually keep a pressure of say 10 kgs. Just in case if the pressure drops or some leakages happen, you want to make sure that the 7 kg reaches to your farthest point of the plant. So that's the basic philosophy that we have been using. But sometimes what happens is, basically if the system is very well designed, or it's a new design, there are no leakages in between, the 10 kg automatically gets passed on directly to the 10 kg at the end. So that 3 kg extra pressure that you are actually providing is actually loss of energy. That is one. Second thing is, if there is a leakage in between means anywhere at the end point also, or in between anywhere, higher the pressure is there, higher the leakage is there. because more the pressure is there, the more leakage of that product is going to happen. Maybe it's air, maybe it's chemical, maybe it's water, maybe it's some kind of a heat energy, whatever you are transferring. The more the pressure, the more losses are. Now I'm talking about these are the process losses. Same way you are also having the energy losses, because all the motors are running at your maximum speed. So you are not reducing any speed, you are not actually controlling any kind of frequency. So if a motor is having say 10 ampere current load, it will continue to have 10 ampere current load irrespective of whether you are actually crossing the pressure threshold required at the end. So putting a VFD in the complete system gives you two things. First of all, it is going to control the amount of the pressure which is required at your farthest end. So you can directly interlock, like you need a pressure at a farthest end, say at 7 bar, you can directly put a pressure transmitter over there, get that signal back to the VFD, put it as a set point to that VFD that at this point you need a pressure of 7 bar. The VFD will automatically control the speed and delivery of your product from the pump directly to the farthest point at 7 bar. So it will not bother about what kind of speed it is running on. It will not bother about what kind of the motor behavior is there. It will make sure that you get 7 bar at the farthest point. So it is one of the biggest thing for a pump. So it becomes a closed loop for you. And how the energy saving comes. Now, as you can see, there is a basic example, and this is a basic chart that we have shown how it is going to do and how it is going to work. Now, if you see on the left side of the chart, it is the energy consumption. So we have got energy consumption of 100%. Okay, and then we have got a speed at 100%. And if you see, if the speed is at 100%, you have got energy consumption of 100%. Okay, but if you reduce the speed by around 80%, 20%, so you reach a speed of, say, if you have a 100 rpm motor, you reach a speed of 80 rpm, you reduce by 20%, you actually reduce your energy consumption by 50%. Now I'm talking about the energy consumption of electricity. Apart from that, reduction in the speed is also going to reduce your total load on the system, the pressure surges on the system, any kind of leakages, the leakages will be minimized because of the pressure is very low. Now, if you further reduce this complete speed to say around 50%, automatically, exponentially, your energy saving is going to around 80%. So this is a theoretical calculation. We can help you to find out a proper calculation based on the load factor, motor conditions and all those things also. But this is a tentative idea because we already have the calculations done for this particular thing. It's a standard practice for most of the VFDs you will be getting. You may get say 1%, 2%, 5% somewhere here and there. But most of the saving that you are going to get is in this same line range. So this is the way the energy saving is being achieved by putting a VFD. Now coming to giving you more details on some VFDs is basically VFD controllers are designed to operate 100 volts, 110 volts to 690 volts. These are the basic ones. So we call them as a low voltage. Low voltage means it's a motors are easily available. You can actually manage it in your plant. You don't need any specified trained people to manage it. So that is what you can do. Plus we can get you 0.2 kilowatt is the lowest rating, and then you can get into some megawatts. So you need a 5 megawatt, you need 6 megawatt of the motors on the low voltage 690 volts. It can be done. Then the next VFDs are going out to be medium voltage. Now medium voltage are basically for the high end motors, like mostly this goes to like crushers, cement plants, quarries. There we use. Here the voltages are very high. So if you see, we have got 3000 volts, 2400 volts, 4000 volts, 60 hertz and 50 hertz, depending on the country that you are actually employing that thing. So medium voltage is entirely a different subject. We will have a separate discussion based on this medium voltage. And for now, we will be focusing only on the basic LV voltage, that we call it 110 volt to 690 volts. So this is the main application for this. Now coming to the application where we can install is, as I've explained earlier also, VFDs can mostly be installed on fans, pumps, compressors, any kind of crushing mills. Wherever you want to do, you can install that. Basically any motor, any rotating machinery where you are using electrical motor, you can actually put in a VFD. But the catch over here is, if that VFD is going to control some kind of things like a voltage, if it is going to control some kind of a load, it is going to control some kind of a frequency, only then you should go for a VFD. It is not required that if you are not controlling anything, then you put a VFD. It's always better that you control it. You maybe reduce the speed by maybe 5%. That 5% is actually going to get you some kind of a saving. So that is the reason of putting a VFD. Installation for oil and gas, petroleum, petro industry, you can have all kind of pumps, you can have all the compressors, oil transfer pumps, whatever you want to do it. Same is with the mining, so you have got all the motor pumps, fans and everything, whatever you want to do. Water and wastewater is one of the areas where the VFDs are very much being accepted nowadays, because water and wastewater pumps have to run and deliver for a very big populations nowadays, and they have to be working very energy efficient. So people are putting a lot of VFDs nowadays on the water and wastewater. The conclusions, it's pretty simple, that you must have understood now. The first thing, that once you are putting a VFD, is actually giving you a stable and reliable performance of your power quality. So the kind of the voltages surges which happen in the systems, the kind of the breakdowns that happen in the system, the motors have to face everything. Once you put a VFD in between, the VFD becomes a kind of a protecting device also, because it's controlling the power. So anything wrong happens, it happens to the VFD. It never gets passed on to your motors. So your motors, which are bigger ones, which are costly ones, actually don't have to bear the brunt of the power quality. So most of the quality issues which are in the power are actually taken care of the VFD. So VFD gives you the required quality of power to your motor. Next is, it saves energy. Definitely it saves energy, because end of the day you are reducing your speeds, you are reducing, you are changing your frequency. Based on that, your total energy cost, total ownership of the complete system goes down. And you don't have to calculate the energy saving in the field for say 6 months or 5 months, because the VFDs work for 5 years, 6 years, 7 years. So based on that, you can actually understand even 5% of saving for next say 5 years is going to be a big level of saving for you, and it actually keeps your motors protected. Next benefit is isolated control signal can be given to this. So all the VFDs which need to control, you can actually use nowadays fiber optics. So you can have your controllers kept anywhere in your plant, and power control in a different MCC, and you can actually control it. So these kind of the technologies which are available nowadays with the VFD, and as per your need, you can actually confine, you can actually design the complete system, and it is going to get you the savings. I would like to thank you everyone now for your kind consideration and your time to actually watch this video, understand how the VFDs are working, how the saving can be done. So please try to explore something for you wherever you feel that a VFD can be implemented, wherever you feel that some survey has to be done, or wherever you feel that our input is required for the VFDs. I'm sure this video is going to be good and knowledgeable for all of you. In case you need any further information on this, or in case you want to connect with me, you can directly connect with me by writing a mail to me. So my email ID is manmeetsinghbhatti@gmail.com. It's pretty simple to remember. And I'm also into now coaching and training business. You can actually join my complimentary training courses directly going to my website, that www.coach.manmeetsinghbhatti.com. I thank you again for watching this video. Thank you very much. Stay blessed.